Smart Culture, Mathematics.
Welcome to Smart Culture. Hey, don't forget, hit the like button down below and subscribe to our channel.
This video will be all about trigonometry. Trigonometry deals with the relationship between the angles and sides of a triangle. In this video, we'll specifically look at trigonometric ratios in right-angle triangles, which basically forms the basis of trigonometry. Now, trigonometry is actually a very important topic in mathematics, and we can also use it in everyday life. Trigonometry is used in astronomy to measure the distances to nearby stars. It is also used in geography to measure distances between landmarks and also in satellite navigation systems. GPS, global positioning systems, would not be possible without trigonometry. Other fields such as optics, analysis of financial markets, electronics, biology, medical imaging, and cryptology also make use of trigonometry. Isn't that interesting? Let's start with the very basics of trigonometry, the similarity of triangles. In the triangles below, triangle ABC is similar to triangle DEF. Take a look at these triangles. What do you see? In similar triangles, it is possible to deduce ratios between corresponding sides. AB over BC is equal to DE over EF. AB over AC is equal to DE over DF. AB over DE is equal to BC over EF is equal to AC over DF. Another important fact to consider about triangle ABC and DEF is that the angle at vertex A is equal to the angle at vertex D, and in that same way the angle at vertex B is equal to the angle at vertex E. What about the angle at vertex C and F? They are equal. We also need to talk about the order of letters for similar triangles. A lot of students get this wrong. Remember to always label similar triangles in corresponding order. For example, triangle ABC is similar to triangle DEF. This is correct, while triangle ABC is similar to triangle DFE will be incorrect. Next, we'll discuss how you can go about defining trigonometric ratios. Take a look at the triangle below. In a right-angle triangle, we refer to three sides according to how they are placed in relation to the angle theta. So the side opposite to the right angle is labeled the hypotenuse, the side opposite theta is labeled opposite, and lastly, the side next to theta is labeled adjacent. We define trigonometric ratios, sine, cosine, and tangent of an angle as follows. Sine theta is equal to the opposite over the hypotenuse. Cosine theta is equal to the adjacent over the hypotenuse. And tangent theta is equal to the opposite over the adjacent. These ratios are also known as trigonometric identities. They relate the lengths of the sides of a right-angled triangle to its interior angle. These three ratios form the basis of trigonometry. Some people call it SOHCAHTOA. Weird, isn't it? Let's take a look at an example. First, find the right angle. The hypotenuse is always directly opposite the right angle. Remember, a right angle is 90 degrees. The hypotenuse never changes position. The opposite and adjacent sides depend on the angle we are looking at. The opposite side relative to the angle theta is directly opposite the angle theta. The adjacent side is the remaining side of the triangle and must be one of the sides that forms the angle theta. Let's complete the trigonometric ratios for theta. So sine theta is equal to opposite over hypotenuse, so it will be CB over AC. Cosine theta will be equal to the adjacent over the hypotenuse, so that will be AB over AC, and then tangent theta will be equal to the opposite over the adjacent, which will be CB over AB. Let's do one last example. Have a look at this triangle. What do you see? In this case, sine A will be equal to the opposite over the hypotenuse, so it will be CB over AC.
For online tutoring or additional resources, visit our website, www.smartcultureeducation.com.
Don't forget to subscribe.